On the evening of the 21st of August 1986, families living beneath Lake Nyos in northwestern Cameroon went about their lives as usual. Meals were prepared, livestock were brought in, children settled down for the night. The lake above them appeared perfectly calm, but hidden beneath its surface was an enormous quantity of invisible gas. And sometime that evening, the lake released it. The gas swept silently down the surrounding valleys and entered homes and villages without warning. There was no wall of fire, no river of lava, no violent storm telling people to run. By the following morning, more than 1,700 people were dead. Thousands of animals had died alongside them. Some survivors awoke after hours of unconsciousness to find that almost everyone around them was gone. How could an apparently peaceful lake kill so many people in a single night? And could it happen again? Lake Nyos lies in a remote mountainous region of northwestern Cameroon in Central Africa. From above, it looks almost impossibly peaceful. Its blue water fills a volcanic crater surrounded by steep green hills. Small agricultural communities had existed in the surrounding valleys for generations. The lake provided water. The surrounding land provided grazing and fertile soil. There was little reason for the people living beneath it to imagine that the lake itself posed a danger. Lake Nyos was not known for violent eruptions. It did not regularly send smoke into the sky. There were no rivers of lava running from its shores. Yet its volcanic origin was the key to what was happening far below the surface. Deep beneath the region lies volcanic activity capable of releasing carbon dioxide through cracks in the earth. Over time, some of that carbon dioxide entered the deepest water of Lake Nyos. Normally, we think of carbon dioxide as the gas we breathe out. It exists naturally in the atmosphere and is invisible and odorless. But in a sufficiently high concentration, it can become deadly. At the bottom of Lake Nyos, the enormous pressure created by the water above allowed carbon dioxide to remain dissolved. It was similar to the way carbon dioxide remains trapped inside a sealed bottle of fizzy drink. As long as the bottle stays closed and pressurized, much of the gas remains dissolved in the liquid. Open it, and the pressure drops. Bubbles suddenly begin forming and rising. At Lake Nyos, this process had been taking place on an almost unimaginable scale. Year after year, more carbon dioxide accumulated in its deepest layers. And because the lake's water remained unusually stable, the gas was not regularly brought to the surface and released. The lake looked calm because its layers were barely mixing, but that calmness was helping create the danger. On the night of the disaster, something changed. Exactly what started the event remains uncertain. Scientists have considered several possibilities. A landslide may have disturbed the deep water. Heavy, cool rain may have altered the balance between the lake's layers. There may have been a small earthquake or underwater disturbance. It is also possible that the gas-rich water had simply become unstable enough for the release to begin without one dramatic external trigger. Whatever happened, some of the deep water began moving upwards. As it rose, the pressure surrounding it fell. Carbon dioxide started coming out of the water as bubbles. Those bubbles lifted more water towards the surface. That released even more carbon dioxide. A self-reinforcing chain reaction had begun. It was like opening an enormous bottle that had been shaken and pressurized for years. Gas-rich water surged upwards. A violent column of water and foam appears to have erupted from the lake. Evidence around the shore suggested that the disturbance produced a powerful wave, stripping vegetation and moving debris. The lake's normally blue water later appeared reddish-brown as iron-rich water from the depths reached the surface and reacted with the air. But the most destructive part of the event could not be seen. A vast quantity of carbon dioxide escaped from the lake. The gas briefly rose above the water, but carbon dioxide is denser than ordinary air. Instead of dispersing harmlessly upwards, much of it sank. It poured over the edge of the crater and began flowing downhill. The surrounding valleys acted like channels. The gas hugged the ground, moving through low-lying areas towards nearby communities. It behaved less like smoke and more like an invisible flood. Only instead of filling homes with water, it displaced the breathable air. The first communities in its path had almost no warning. Some survivors later recalled hearing a distant rumbling sound. Others remembered losing consciousness without understanding why. Many of the victims were already asleep. Others collapsed while cooking, walking, or attempting to discover what was happening. Because carbon dioxide has no color, people could not see the danger approaching. At dangerous concentrations, exposure can cause rapid breathing, confusion, loss of consciousness, and death. The gas cloud replaced the oxygen people and animals needed to survive. Across the villages of Nyos, Cha, Subum, and surrounding settlements, homes became silent. Cooking areas were left as they had been. Livestock collapsed in their enclosures and fields. Birds, insects, and other animals were also affected. The cloud travelled for many kilometres through the valleys. By the time it dispersed, 1,746 people had been killed. Approximately 3,500 cattle and other livestock also died. Hundreds more people were injured or suffered symptoms associated with exposure. The pattern of destruction was bewildering. Buildings had not been flattened. Trees throughout the villages had not been burned. There were no obvious injuries explaining the enormous loss of life. In some places, survival came down to geography. People on higher ground were more likely to escape the densest gas. Low-lying homes and valleys were far more dangerous because the heavy carbon dioxide collected there. Some people remained unconscious for hours before waking. When help began arriving, rescuers encountered entire communities in which only a small number of residents had survived. At first, nobody could be certain what had happened. The absence of conventional damage led to frightening rumours. Some wondered whether the villages had been exposed to a mysterious disease. Others suspected a chemical attack. The idea that a lake could suddenly release an invisible cloud capable of suffocating communities was almost unknown. But there had been a warning. 2 years earlier, in August 1984, a smaller disaster had occurred at Lake Nyos, another volcanic lake in Cameroon. 37 people were killed in circumstances that initially seemed equally mysterious. Victims were found along a road and in nearby areas with little visible explanation for their deaths. Scientific investigation pointed towards a sudden release of carbon dioxide from the lake. But the scale of the danger posed by other volcanic lakes had not yet been fully understood. After the Lake Nyos disaster, scientists from Cameroon and other countries travelled to the area. They sampled the lake at different depths. They examined the chemistry of the water. They mapped the affected valleys and studied the pattern of human and animal deaths. The evidence increasingly supported an extraordinary conclusion. Lake Nyos had experienced what is now commonly called a limnic eruption. Unlike a conventional volcanic eruption, this event did not require lava or ash to reach the surface. The eruption came from gas stored within the water itself. A deep lake can hold an enormous amount of dissolved gas because of the pressure at depth. If that gas-rich water rises and begins releasing bubbles, the process can accelerate rapidly. The tragedy had revealed a rare category of natural disaster. Only a small number of lakes are known to possess the particular combination of depth, volcanic carbon dioxide, and stable water layers required to create this threat. Lake Nyos is one of them. Lake Nyos is another. Lake Kivu, on the border between Rwanda and the Democratic Republic of the Congo, also contains very large quantities of dissolved gas. Although its size, chemistry, and risks are different and are monitored separately. Discovering the cause of the Lake Nyos disaster created another urgent question. The source of carbon dioxide beneath the lake had not disappeared. Gas could continue accumulating. How could another disaster be prevented? Scientists and engineers proposed a remarkably simple-sounding solution. They would install pipes reaching from the surface of the lake down into its gas-rich depths. Water would initially be pumped upwards through a pipe. As the deep water rose and the pressure decreased, carbon dioxide would form bubbles. Those bubbles would make the water column lighter and help pull more deep water upwards. Once started, the process could continue largely under its own power. Instead of allowing gas to accumulate until it escaped catastrophically, the system would release it gradually and under controlled conditions. A permanent degassing pipe began operating at Lake Nyos in 2001. Additional pipes were later installed to increase the rate at which carbon dioxide could be removed. The result was one of the most striking engineering responses to a natural disaster. A fountain of gas-rich water rising from the middle of the lake became part of the effort to prevent the lake from becoming dangerously charged again. Monitoring and risk reduction have continued because Lake Nyos is not a problem that can simply be forgotten. There have also been concerns about the stability of the lake's natural dam and the consequences that its failure could have for communities downstream. The disaster, therefore, changed more than the lake itself. It changed how scientists understood volcanic lakes. Before Lake Nyos and Lake Nyos, the idea of a deadly limnic eruption was barely recognized outside specialist scientific discussion. After 1986, the world knew that a lake could store a lethal quantity of gas without appearing obviously dangerous from the surface. The tragedy also demonstrated how geography can shape an invisible disaster. Carbon dioxide followed the valleys because it was heavier than the surrounding air. The landscape carried it towards communities, just as the shape of land directs floodwater. And because the gas could not be seen or smelled, people had no clear signal telling them where safety might be. Today, Lake Nyos once again looks peaceful. Green hills surround the water. Clouds move over the crater. From a distance, there is little to suggest what happened there on the 21st of August 1986. But beneath that calm landscape is a reminder that natural disasters do not always arrive with noise, flames, or visible destruction. Sometimes the most dangerous threat is the one nobody can see. For the communities around Lake Nyos, an invisible gas transformed an ordinary evening into one of the strangest and deadliest natural disasters of modern times. A lake had appeared to exhale, and by morning, more than 1,700 people were gone. Lake Nyos was not the only apparently ordinary place hiding an extraordinary danger. In the next episode, we follow the remarkable true story of a woman who survived not one, not two, but three of history's most infamous maritime disasters. Subscribe to continue the series.